Different about a hyperbola equation than an ellipse equation? You don't have to write this down, but just what's different about the equation? Right, there's a minus sign, right? So that's something that's different. What's different about how you find A and B for a hyperbola than for an ellipse? In an ellipse, A is always bigger, right? What about for hyperbola? Right, so this is A because it's based on coming first, right? Not necessarily bigger. And so we also renamed our major and minor axis, right? The major axis and the minor axis for an ellipse were the longer and the shorter axis based on size. And for an ellipse, I don't think I mentioned conjugate yesterday, but transverse is just whichever one comes first. The other name is conjugate. I'm not going to test you on the word conjugate, but that's whatever axis comes second in the equation. So major and minor become transverse and conjugate. And then there was one other difference that I'll put up on the board, but I'm just writing for the purpose of this video right now. C squared is now A squared plus B squared for a hyperbola, right? So there's a new relationship between A, B, and C that we also need to keep in mind. So I'll put that equation up on the board just so C squared equals A squared plus B squared. All right, so tell me about this first equation. Which term is coming first? The y, right? So that tells me that A squared is 25, and that tells me that my hyperbola is going to go in the vertical direction, which means up and down vertically. So when I sketch my hyperbola, I can look back at this drawing, know where to put my curves. The center is at 0, 0 because there's no parentheses around the x squared or the y squared. So I can mark my center at 0, 0. And then in the y direction, I take the square root of 25, that's 5. So I'm going to walk up 5, 1, 2, 3, 4, 5, and down 5, 1, 2, 3, 4, 5. And then in the x direction, I'm going to go 6 units because the square root of 36. 1, 2, 3, 4, 5, 6. And these are just the endpoints of the conjugate axis. So we've got the vertices, those are on the transverse axis. These are just considered endpoints of the conjugate axis. So then you make a rectangle. Was everyone here yesterday for hyperbola intro? Yes, right? Okay. So this is familiar to everyone in here. So here's your rectangle goes around all of those endpoints. If it had been an ellipse with a plus sign, we just would have connected them and that would have been our ellipse. And then you can use a ruler to draw in the diagonals of your rectangle. So there's the diagonals of your rectangle. So those are the asymptotes of your hyperbola. And then you go back to your original picture and you see how your curves need to come off those top and bottom points on your axis. So the only hyperbola on this whole graph is this yellow curve and this yellow curve. Everything else is just a framework of the hyperbola. So that's, I'm going to give you a question like that probably on your quiz or test where it's given to you in the correct standard form and you just have to graph the hyperbola. There's two other pieces that you need to include, the C value and the equations of the asymptotes. So the C value I'm going to find using the equation C squared equals A squared plus B squared, and I'll give you that equation on your quiz. And so I'm going to add together 25 plus 36 and then take the square root of that to get C. So 25 plus 36 is 61. And the square root of 61 is 7.8. And you go in the vertical direction from the center. So this was 5, 6, 7.8. 5, 6, 7.8. So your foci are inside the curves. And if you remember the definition is if I pick any point on my 90 and 30 or something like that, right? 90 minus 30 would also be 60. So you can find it by subtracting the difference between those 2 points. All right, so the last step is to write the equation of the asymptotes. They go through 0, 0, so I can use slope-intercept form. And so slope-intercept form is just what's the rise and what's the run. I went up 5 and I went over 6. So my asymptotes are just plus or minus 5, 6x, right? Because it's y equals mx, and b is 0 in this case, because the y-intercept was 0. All right, so now you're going to try example 2. Let's just make sure. Oh, you know what? I need to change example 2 because it goes way off the graph. Let's just change this to x plus 3 squared instead of x plus 7 squared, because it went way off the graph in the other class. Well, maybe we'll do this one together too, just because it's in a different order. It's got a different center. All right, so x is coming first, right? If x comes first, we're going to have a horizontal hyperbola in this direction. So a squared just comes first, right? A squared in the first example was the smaller number, 25 versus 36. A squared in this problem happens to be the bigger number. It doesn't matter if it's bigger or smaller. It only matters that it comes first. I'm going to go left 3 and down 8 to plot my center. So left 3 and down 8. I just changed the value so that it'll fit on our graph here. And then in the A direction, so X direction, I'm going to count 5 units. 1, 2, 3, 4, 5. Sorry, this printed so light. 1, 2, 3, 4, 5. Hopefully you can see it. In the Y direction, I'm only going to go 1 because the square root of 1 is just 1. So this is a really small, narrow rectangle to box it in. And then you can go ahead and draw in your diagonals and your hyperbola. And go ahead and solve for C on your own. And we can write the equation of the asymptote together in point slope form in a minute. All right, so see if you can draw in your hyperbola and your C value. So we should have it opening horizontally, right? These little tiny curves. So you can see hyperbolas come in different shapes, right? Just like ellipses come in different shapes. If this had been in the wider part, it would have been a really wide hyperbola. It's in the narrow part, so it's a really squished hyperbola. Your C value is almost on top of that vertex, right? It was only at 5.1 units, and this was 5 units. So the focal point is really close to the vertex. So to write point slope form, the format is y minus y1 equals m x minus x1. x1 and y1 are just a point that are on your line. So we're going to use the center of the hyperbola because your asymptotes go directly through that center point both ways. And so you can grab the parentheses from your original problem because x plus 3 and y plus 8 defined that center point. You always put y equals on the left because this is an equation of a line. So we're going to put y plus 8 on the left equals plus or minus. What is our slope this time? We rose 1 and we ran 5. So plus or minus 1/5 and then x plus 3, we can take directly out of the original equation because that's what moved our center left 3. So x plus 3 and y plus 8 define -3, -8 as our center. And the asymptotes go through that point. And you use plus or minus just because one's going in the positive direction and one's going in the negative direction. All right, so there's one more I want to do with you before you do a couple for practice. I want to go back to example 4 from yesterday, so that was on page 407. We haven't done this one in here yet, right? Because I said we would try completing the square another time. So I want you to notice something about this equation. I just need a blank sheet of paper. So on your test next week, you're just going to get an equation and you're going to have to figure out, is this a circle, an ellipse, a hyperbola, or a parabola? So I just wanted to start planting the seed for you of how just by looking at one of these equations, you can figure out what it is. So if you had that equation, that equation, that equation. We haven't done parabolas yet, but I'm going to show you how you know if it's a parabola. Okay, so out of these 4 equations, well, actually only the top 3, ignore the parabola for right now. How can I tell which one of these is going to be a circle? So I put one of each. I put a circle, an ellipse, and a hyperbola. Just by looking at the equation, you should be able to predict what type of shape it's going to be. So can you look at the equation? How could you tell the difference? What? All right, so this is a circle. Do you see that? Because these have the same coefficient, and I could just divide through by 8 to start the problem. There is a plus sign. They have the same coefficient. So that's my circle. All right, which one's my ellipse and which one's my hyperbola? How could you tell? So we've got, just from the starting 2 values, you can actually tell if you've got an ellipse or a hyperbola, right? This has to be an ellipse because you're adding your 2 squared values together. So just, I want your brain to start reading these equations. These are different shapes and the equations are slight differences that give you these clues. There's a minus sign right there. So this has to be your hyperbola. When we throw the 4th conic in on Friday, how can you tell that this isn't like the other 3 equations? Right, there's either going to be one y squared or one x squared in the equation and not x squared and y squared. So this will tell you that it's a parabola when we get to that, because only one of the terms gets to be squared. So you're trying to use those clues when you get an unknown equation. So on the test, it'll just say, what type of conic is this? Right? So I know this is a hyperbola because of the minus sign right there. And in the past, we were sorting out our equation and we always kind of put x squared first out of habit, and we always put y squared second just out of habit. If the minus is with the x squared, you want to put that second. So whatever's minus has to go second. So for this hyperbola, you're going to do your 9y squared minus 36y first, then minus 4x squared plus 8x second, and then move your 4 to the other side of the equation. So whatever is minus gets to come second. Then the same step, you factor out your 9 for this first trinomial. So you'd have y squared minus 4y. What do I use to complete the square inside that trinomial? So I cut this number in half, -2, and I square it, right? So I'm going to add 4 in this position. What do I need to remember to add to the other side? 9 times 4, right? So I'm going to add 36 to the other side to keep it balanced. Okay, this is where students make some mental math errors. I need to factor out a -4. So you need to remember to divide the 8x by -4. So it actually changes the sign of that term. You actually have x squared minus 2x, right? Because 8 divided by -4 would be -2. You can double check that you did it correctly by just distributing. -4 times -2x is positive 8x. So I know that this is equal to this. So now what do I complete the square with? I cut this number in half, -1, and I square it. So I'm adding 1 on the line. What do I need to do to the other side? -4 times 1, I need to subtract 4 on the other side of the equation. Then, now you're just in that same step from ellipse world. Write the completed square for each of these trinomials. So this would be 9y minus 2 squared, because half of this -4, right, is -2, and -2 squared is that +4. So minus 4. This is just going to be x minus 1 squared. What do I have? I have +36 on the right-hand side. So the last step is dividing through by 36, because the hyperbola needs a 1 on this side, just like the ellipse gets a 1. So divide by 36 backwards, and then reduce each of these fractions. I kind of ran out of room. I'm going to write my answer down here. So I've got y minus 2 squared over 9 over 36 would reduce. I could divide by 9 and I would just have 4 left in the denominator, minus x minus 1 squared. I would reduce by 4, so I have 9 left in the denominator, 436, and then equals 1. All right, so see if you can take this one, see if you can, we know that it's going to be vertical, right, because y is coming first. So make sure when you draw your ellipse or your hyperbola, you're going to draw a vertical hyperbola. You can locate your center. This is your x, this is your y. Find your a and b values and try to sketch your graph. If you need help on the asymptotes, I could help you. And so then I want to check your answer to example 4. And I want you to try on your own page 409, number 5, which is another completing the square problem for hyperbolas. And then, pick another problem on there if you still have time. But finish this one first. So this was this example. You're going to finish, and I'll put up the answer to example 4. And a common mistake that I keep seeing from people, not necessarily in this class, but even though x came second in the equation, x always defines the x value of the center. So it's right 1 up to, even though the y comes first, this is still the x coordinate of the center. So 1, 2, and then that's why I had you write out the a and the b value, because those are the square roots of the numbers from the formula. And that's how far you walk when you're planning the endpoints of your axis. So now you're going to skip ahead. And the last one I want you to try for hyperbolas today is seeing if you can complete the square yourself on number 5.